Okay, so we just decided that example number 1 here has 3 solutions because that exponent right there is a 3, so that means there's 3 solutions. You already know this, right? Okay, so we go to y equals, go into our graphing calculator, and we plug in that equation, 2x to the third plus 6x minus 4, right? And then go to the graph. We know there's supposed to be 3, right? And you can't really see the whole thing, so let's just zoom out. Let's see what happens. Yeah, sure, go for it. Mario, can you shut that other light off? Thanks, man. And then watch this. Can you see that better? Yeah? Okay. So if you can see, oh wow, hey, brightness.
Really bright, man.
There we go, that's better. So as you can see, how many times does that graph cross your x-axis? Once. Okay, so what does that tell you? Yeah, what does that one tell you? There's one real solution.
Okay.
And if you know there's 3 total, then what are the other 2? They're not fake, they're imaginary. 2 imaginary. 2 imaginary solutions. Okay. Did I confuse any of you?
Me.
I'm so sorry.
Not me.
Okay. On B here, how many solutions total should we have? We should have 4. So 4 solutions total.
The biggest exponent.
Yeah, the biggest exponent. You see how there's a 4 and a 3? Yeah, we need the 4 because it's the biggest one. So now we go to y equals, and we clear out that calculator. It's kind of glary. I'll bring it down. We've got 3x to the 4th minus 2x cubed plus x minus 1 graph. And it's on your test, okay? And let's zoom in. If we go back to zoom standard here, if we go back to zoom standard, okay, looks like a parabola. It's not one, but it looks like one, okay? What does that graph tell you?
It crosses twice.
It crosses? Funny. Crosses how many times? Twice. So what does that tell you?
2 real solutions.
Very good. And how many are imaginary?
2.
Okay.
Oh,
Yeah, I thought that too.
I sent a remind. On C here, how many should we have total?
4.
Yep, we should have 4 solutions total.
Plug in the calculator.
And we go to y equals. Very good, Eric. 2x to the 4th. I know mine's not as colorful as yours, but that's okay. Nope.
I'm tired of getting 5.
Okay. So now we're here. I'm going to zoom in.
It crosses
Yeah, let's
twice.
zoom in.
It doesn't cross the x.
It doesn't cross. So what does that mean?
0.
Well, there's 0. Yeah, there's 0 real. All are imaginary. 0 real solutions.
Can we just put all imaginary numbers?
Sure. He asked if you could put all imaginary instead of 4. That's fine. 4 imaginary. Okay? Great. Okay, so that's the stuff that you did know. Here's the stuff that you don't know. Turning points are known as, we call them local maximums and local minimums. Okay? Local maximums and local minimums. Okay? A local maximum is just a point that is higher than the points around it. And so that means that a local minimum is just a point that is lower And I'll draw you a picture of all these in a second. A point that is lower than the points around it. Okay?
That's what we call it.
Oh, geez. Okay. The turning points of a graph help determine the intervals for which the function is increasing or decreasing. And I will put these on my picture here in a second too. Okay? So these are all new vocab words for you. You haven't really learned them yet. Okay? God bless you.
You want to know?
Okay.
Wait. Lower than the points around.
Okay. So, I'm going to draw you a picture. Ready? Think of like a roller coaster. Okay? That's a roller coaster. That's the best roller coaster that I can draw at this point. Okay? Oh, thank you. Appreciate it. Okay. This point right here, you see how it looks like a maximum, but there's another maximum over here, and we don't really know what happens outside of the picture, right? Okay, if it looks like a maximum, but there's more than one, that's what we call a local maximum. And there can be more than one. So there's a local maximum right there, and there's also a local maximum right there. Okay? It's like higher than the points that are around it. Like if you were going up on a roller coaster, at what point would you be at a high point? Okay?
Yeah.
So then, what do you think this is? A local minimum. Very good. And there's also one, I know it doesn't really look like it, but we could probably call something over there a local minimum too. I just kind of sketched this picture, so I don't really know what happens after it. Okay? So those are the minimums and maximums there. And then when it talks about increasing and decreasing, that just means are you going uphill or downhill? Okay, so on the way to this local maximum, you're going uphill. Is that increasing or decreasing? It's increasing. Very good. What happens as you turn and you go back to the next one? That's decreasing. Then what happens? You are increasing again. And then what happens? Then you decrease. Yeah, it looks like a lot of common sense, isn't it? And looking at your picture, you can show me where it's increasing or decreasing, but actually writing how I want you to write it, that's what's difficult. And so when we get to our example, I'll show you what I want. Okay? Have I confused you yet? That's a whole lot of definitions and just random things. Now we actually get to graph. Okay? Now here's my goal here, because I don't want you to sit through me doing a whole lot of examples. I'm gonna do these next two examples, okay, and then I'm gonna do two others that are kind of later on, and then I'm gonna let you fill in the blanks and work on the others. Big ideas, guys, I'm gonna warn you, is not great for this section. I don't think I assigned many problems for it, and so most of your practice is going to be in this packet, and that's all you get for your test. So at the end, when I give you time to work on it, I need you to actually work on it and check your answers to make sure that you got the concepts, because Big Ideas doesn't do all of this. And I test over it. Following my thing here? Okay. Yeah, picking up what I'm putting down. Very good. So I'm not going to make you sit through all these examples, but you're still going to be expected to do them at the end. Okay? Just a disclaimer. Okay, great. Moving on. First example here. When you see the word graph, what's your first instinct? Graph it. Plug it in the graphic calculator. Very good. We go to y equals. We do 1/6 x plus 3 x minus 2 squared. And we go to the graph. Okay? And then, if you've been following along with me, your graphing calculator might be zoomed in too far. So if you hit zoom and then go down to zoom standard, which is number 6, you'll be able to see your graph a little bit better. Is that what yours looks like? Yeah? Okay. All right. So basically what we're going to do is we're going to fill in this box first, and then I'm going to go and sketch my graph. Okay, because once you fill in the box, sketching the graph is just pretty simple. Okay. So let's look at the zeros. Now, we already learned how to tell what the zeros were from this, right? What are the zeros here? -3. What else? And +2. Now, if you didn't know that, if you forgot about that lesson, you could hit second graph and go to your table and look at where there's a 0 on the y's. So there's one at 2, and then there's one at, oh, why doesn't it go past that? There we go, that's why. And then there's one at -3. Now, the one thing that you do have to do that I didn't put in here is you have to tell me if they cross or if they bounce. And you can either tell me that by looking at the graph or just by the fact that if there's a 2, what does that mean? It bounces. And if you can look at your graph, you can see that there's a bounce at the 2. And then what happens at -3? We cross. Very good.
Am I still gonna get extra credit for that song?
For what?
That song?
Yeah, if you make it and it's good.
Gotcha.
Okay. All right. Now let's look at our y-intercept. It's kind of hard to see on our graph, but if you go to your table, your y-intercept happens when x is 0. Okay, so if you look in your table where x is 0, it happens at 2. So your y-intercept is at 2. Okay? Did I confuse you there? Are we all okay with me so far? Yeah? All right. End behavior. All I want for end behavior are arrows. What's the first arrow that I draw? Do I go down or up?
Up. Down.
Where does it come from?
Down.
It comes from, all right? And then what's the next one? Up. Okay, now you could have also, remember when we decided the end behavior, you looked at the degree and the lead coefficient, right? What's the degree of this polynomial?
Even.
Well, there's two here, and then how many are here?
2.
No, how many zeros are right here? There's one there, so you have a total of 3. And an odd degree told you that you went opposite ways, right? So you either went up, down, or down, up. And then this lead coefficient, because it was positive, that told you that you ended up. Do you remember that? Maybe? Okay. If not, you can just look at your graph. It comes from here, so that means that there's an arrow down there, and that it goes until forever and ever that way. I don't really care. Whoever is taking pictures and Snapchatting needs to stop. Thanks. Appreciate it.
No, that was just mine.
Uh-huh. Okay. All right, maximums and minimums. This is something that is new. Okay, so follow along. Here we go. To find the maximum, we know that the maximum happens right there, right? But we don't know what that coordinate is. So we're going to hit second, then trace.
I think it's -1, 3.
But we don't know. That's what we're trying to find out. Second, then trace.
Where's trace?
Okay? Trace is the
We're trying to find a maximum.
and we're trying to find a maximum. We sure are. Okay? Now it's asking you this question, left bound. And it's asking you, is your blinking dot to the left of your maximum? And we're not to the left of the maximum. So we're going to hit that left arrow over until you're to the left of your maximum. Anywhere on that side is fine.
It's just like that one thing we did.
Uh-huh. Sure is. Okay? I think we did this with parabolas, right? Did we do this with parabolas?
It was something.
Something? Okay. Then it's asking you for your right bound. So you hit that arrow until you're all the way to the right over there. And then you click enter, and then it asks you that stupid question, do you want me to guess? And you're like, yes, I do.
1.3.
And then we've got, this is what you write, -1.3, comma, and then round maybe 3.01. If you put y equals 3, I'd probably count that. Yeah.
And then we do the minimum.
And then we do a minimum. We sure do. So hit second, trace, go down to minimum, click enter, and it's asking you are to the left. I like to go a little bit closer to the left.
Is that a 3.0?
It's 3.01. Yeah. Sorry, the lighting's
I got
probably a little off.
1.2.
Okay, so you hit your left, you arrow over until you're to the right, you hit enter, then you hit enter again. And that right there is a 2. Now here, I'm glad this popped up. Do you see this right here, how it says e to the -12? Do you see that? Okay, do you know what that means? That means that you have 1.8 and then you have 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's actually, your decimal's actually right there. That scientific notation. What is that in reality? It's 0, which should make sense, right? Your minimum happens at that bounce. That should happen. Huh? There's only, well, there's 12. Okay, so anytime that you guys see e to the negative 10, e to the negative 14, e to the negative 12, that's 0. Okay, 0.
For the minimum, I got 1.6 for some reason.
I don't know what you did. All right, increasing and decreasing. Now, this is where I am going to stop and graph what I see. Okay, so I'm just going to basically look at what I've already have, and I'm going to put it on the graph. I know I have a point at negative 3 and a point at 2. I know my y-intercept is a 2. Okay, and then I also know that I have a minimum at 2, 0, which I've already graphed. And I have a maximum at negative 1 1/3, which is about there. And then 3.01. So somewhere in there. Rough sketch, it doesn't have to be perfect. Okay? And then I just kind of look at my graphing calculator and I make my graph kind of look like that. Again, it's just a sketch. Okay?
What if you want to be precise?
That's great. Okay?
Can I try to do what we done with this?
Sure can.
Increasing interval on laptop.
Okay. So now we got to talk about increasing. Okay, from here to here, you guys probably understand you're increasing, right? We're going to start from the left, go to the right. We're increasing until we get to this point right here, okay? Are we all okay with that concept?
Yeah.
Now, when we're talking about increasing and decreasing intervals, make this note, we're talking about x coordinates, not the y's, the x's, okay? So what that means is that we're going to increase, okay? And x is basically, we're coming from infinity, right? Okay, so as long, x is, we don't have to define what's down there necessarily, but x must be less than, what's this x coordinate right here that corresponded to that point? No, what's this x coordinate right here? That's your maximum, right? What's the x coordinate of your maximum? Negative 1.3. Okay, so x has to be less than negative 1.3. And as long as x is less than negative 1.3, that's talking about everything over here, then you're good to go. Okay? But then we're also increasing again, right? Where else are you increasing? Right, from here on. So we're talking about all the numbers bigger than what? What's the x coordinate of that minimum there? What's the x coordinate of this point? 2. As long as x is bigger than 2, you're increasing. Okay? Now let's talk about where we're decreasing. We're decreasing in between here, right? Okay, so that means that x is in between two values. Remember drawing an inequality like that? Okay. What's the x coordinate of that point up there? What's that x coordinate? That's our maximum. What's the x coordinate of your maximum? Negative 1.3. And then we go until we get here. What's the x coordinate of that one? Positive 2. That's probably the hardest part of this whole thing, right? I anticipated that it would be. Excellent. Okay. Let's do this next one, and then we'll do one more. And then I'll let you work on your own. Okay? What's the first thing you do? Plug it in the calculator. 1/4 x plus 2 x minus 1 x minus 3. Okay?
How you finish that?
And then look at your graph. Okay. What are my zeros? -2. What else? 1. And what else? And 3. And he either saw that on his graph, or you can go to your table and see that -2 is a 0, 1 is a 0, 3 is a 0. Okay? All right?
Also, it's 3 is
That's fine too. And then what happens at all of those zeros? Do you cross or bounce? Can you see it? Oh, there it goes. It crosses. At which ones?
2, 0, 2.
Are there any that bounce? No, there's not any that bounce. They all cross. You're going to get lost where? So a bounce is when it looks like this, Eric. When it comes down and it bounces up like a bounce ball. Like, yeah, that's a bounce. Crossing is when it looks like this. They cross the axis. It's like you're diving into an ocean or you're diving out of an ocean.
But don't you like bounce back up?
Well, yes, but we want to bounce specifically on the axis. That's a good question. Okay. Y-intercept. I like to go to my table, and this is where the x-coordinate is 0. And so what's my y-intercept?
Is it
1.5. Okay. Now let's go to the graph. What are my arrows? Down, then what's next? Up, and I can just see that on my graph. Okay?
Yeah.
How do I find the maximum?
Second trace.
Second trace. Oh, that's the wrong one. Second trace. Maximum. Enter. We go to our left. We go to our right.
0.78.
So you got negative point. I'm going to round if that's okay to negative 0.79. And then 2.05. And then the minimum, same thing. Go there. Go there. 2.1 and negative 1.02-ish. Rounding, I'm not going to take off for rounding unless you're just way off. Okay? Okay. So now I filled in all of that. Now let's go and write it on our graph. Okay. A -2, a +1, and a +3. Those are your zeros. You have a y-intercept of 1.5, so that goes there. Okay. Then we've got a maximum of negative 0.79. So that's almost to -1. Not quite, but almost there. And then up a little bit over 2. And then a minimum at 2.1. And then negative 1.02. So that's a little bit over -1. Again, just estimate. I don't expect it to be perfect. And then you can connect your dots. It should, hint, hint, wink, wink, look like what you see on your calculator. If it doesn't, guess what, friends? You did something wrong. Okay? All right, let's talk about increasing and decreasing intervals, because this is probably where you need the most help, right?
Yeah.
Okay. So I like to do all of my increasing first and then go to decreasing. Okay. So we're increasing coming up from here. Think of a roller coaster. If we were on a roller coaster, we would be going uphill until we get to this point right here. And what is the x coordinate of that maximum? What's the x coordinate of that maximum?
Negative 0.79.
-0.79.
Oh,
And we know that everything before that is increasing. So that means that x has to be less than that. Anything less than that number works. Okay?
That's not what I have on my calculator.
What do you mean?
I have the right equation.
It's not the graph that you see. Oh, you used a negative instead of a minus. It matters. Okay, and then we're increasing again right here, right? You see that? Yeah? What's the x coordinate there of that minimum? 2.1. So x has to be bigger than 2.1. X has to be bigger than 2.1. Okay? Decreasing. We're decreasing from there to there, right? So that means that x is in between two things. What's the x coordinate of the lower bound?
0.79.
-0.79. And what's the biggest that it can be? It stops here. 2. It can be 2.
Yeah.
Okay? Does that kind of better than the last time?
I think he did. You see that?
He's sleeping one eye open.
It's fine.
It's cool. He got A.
Okay. Ready? One more, and then I'm done torturing you. Let's go.
He said 2 more.
Let's do, yeah, I think I lied. Let's go to 23. Page 23.
Corner one.
Let's go to page 23. Okay? Page 23 here.
Hello, Mike.
All right. And let's go ahead and put it in our graphing calculator. We've got x plus 2 squared,
X plus 2
x plus 4 squared,
squared. X plus 4
Yours should look like a W, does it?
Yeah.
Yeah? Okay, excellent. So, that's good to know. What are the zeros? -2 and -4.
Does not cross the
And it doesn't cross, so then what happens at those zeros? They're both bounces. Excellent.
bounce in. Oh, yeah, I forgot.
A bounce and a bounce. Okay. Excellent. The y-intercept. It is 64. How'd you get 64?
Exact of the table.
You went to the table, and so what he did is he went to 0. Oh, sorry, you can't see.
Okay.
On your table, you're interested in where x is 0.
So find the y-intercept, you go all the way to where you see 0.
Yeah, you go to the table, and you find x equals 0. Okay? All right, what happens to the end behavior here?
Down and up.
If I were to put arrows on the ends here, what would they be?
Up and down.
Up and up.
Up and up, right? That's where both ends of your graph are headed, up and up.
That's where both ends are headed.
Because if you were to put arrowheads on the ends of these right there, they'd both go up, right? Okay. All right. All right, now let's look at those maximums. There's one maximum. It's in between there. You see that? Right there? It's right in here. So let's find it. We got a maximum. And it looks like we're going to have to move our arrow. Oh, there it is. You might have to move your cursor till you see it. Okay, so we go to the left of our maximum. Then we go to the right. Then we click enter again. What happened? When's your maximum? Negative 3 what? Negative 3, 1. Okay? Let's look at these minimums. Be smart. If we bounced on the axis, are we going to go below that?
Nope.
No. So where are your minimums? The two sides right here? Okay. And what are those coordinates? Do you know them? Do you even have to do the minimum feature on your calculator? No. It would be negative 2 and negative 4. Okay, so your minimums are going to happen at negative 2, 0 and negative 4, 0. Now you could have done second, then trace, minimum, and then gone to the left, and then gone to the right, and then click enter, and it would have given you the same thing, right? Negative 4, 0. You could have done that, but you already know it, so don't do more work than you have to. Okay, so let's graph this, and then we'll talk about increasing and decreasing. We know we're at negative 2 and negative 4. I'm not going to graph my y-intercept. It's like way up here. If you want to, you can. You can count by whatever you want to and then find it. What? Like all the way up here? Sure. Whatever you want. I have a maximum at negative 3, 1, right? And then I've already plotted my two minimums, so then what I'm going to do is just do this. W. Just like that. Okay? All right, almost done here. Let's talk about where we're increasing. What's happening right here? Are you increasing or decreasing here? You're decreasing. Okay, so since we're already decreasing, let's go ahead and write that. We're decreasing. What is the x coordinate right here where we stop decreasing? Negative 4. Okay, so as long as x is less than negative 4, we're decreasing. We're going downhill. Okay, where else are you going downhill? Where? Okay, so right here, are you decreasing this way or to the left? Like if we're going from here to here, are you decreasing or increasing? If you go from, like if you go here on up, what is that doing? That's increasing. Okay, so that means that we're decreasing from there to there. So if we're going in between 2 points, that means that x is in between 2 points. What's the lower bound right here? What is that x coordinate? Well, this is a minimum, or this is a maximum. What's the x coordinate of your maximum? Negative 3. And then what's the biggest that it can be right there? That's the negative 2. Okay. Okay. And then let's look at some increasing intervals here. We've already talked about how that's decreasing and that's decreasing. So now we got to talk about what's happening in between those 2 points, which is increasing, right? I know my paper's marked up here, but can you tell that you're increasing from that point to that one? Yeah? So we're in between two things. What's the lowest you can be? What's the x coordinate right there? That's a negative 4. And what's this x coordinate right there? The negative 3. And then we're increasing from this point on, right? Okay. And what is that number? Negative 2. As long as x is bigger than negative 2, you're good to go. So you're going to have multiple increasing and decreasing intervals here. Okay? It's going to happen. What? Looks like what you did in robotics? It looks like a dude on a bike?
Oh, yeah.
Oh, I kind of see it. Yeah, that's funny. It's probably the best drawing of a bike I've ever done in my life. I can't draw. Okay, so there's a lot more examples here. You need to have completed.
3 of them.
You need to have, listen, pages 20, 21, 22, 23, and 24. I'm checking those for 10 homework points on Monday. In addition to the big ideas that's online, that's due Sunday night. But guys, I don't think there's many big idea problems. Okay, so think of it as just like your homework assignment split into 2 different things. All right, you have the rest of the hour to work. I will have my key up here. You guys can check your work when you're ready if you have questions. But keep in mind, this is really the only practice of it that you get before your test, quest, whatever it is. 4-8 is due Sunday night, and I am going to send you a remind on Saturday. Okay, I'm checking those pages that I just said on Monday for 10 points. And then Tuesday, we're learning 4.9. Wednesday is an A day, so you will see me on Wednesday. We're going to review. And then Thursday is a B day, so you won't see me. Friday is a C day, and that's when you have your quest.
Test.
Okay?
Test.
So, do you know my expectations of you?
Yeah.
Great. Get to work.
I can't do homework